Hey everyone, Joe Camacho with Target Specialty Products here, hoping this video finds you, your family, and your team all doing well. I'm here today with my third video in a series of videos dedicated to reviewing mosquito larvicides and their modes of action, along with which formulations are available from Target Specialty Products. In this video series, I'm reviewing the biorational larvicides and biopesticides, insect growth regulators, and finally I'll review mineral oils, and I thought we should move into the insect growth regulators and discuss the IGR Methoprene. Before we jump right into it though, it was brought to my attention by a colleague of mine, someone I really enjoy working with and who self-identifies as an old genetic guy, that I have some terminology misrepresented. It's one of those, a square is a rectangle, but not all rectangles are square situations. See, the old genetics guy pointed out that all biorational pesticides are considered biopesticides, but not all biopesticides are biorational. He explained that a true biorational pesticide does not remove the pest organism from the environment. It leaves it available for predation and other ecological needs, where biopesticides do remove the target organism from the environment by killing the intended pest. It might be semantics, but I appreciate the input and I wanted to pass it along. Now, stay tuned and we'll jump into reviewing the insect growth regulator S-Methoprene. Welcome back. Let's continue with the insect growth regulator S-Methoprene. Methoprene is another type of biorational pesticide, as it is a hormone mimic, specifically a juvenile hormone, and most commonly known in mosquitoes as juvenile hormone 3. See, molting and metamorphosis in insects, such as mosquitoes, are under the control of two hormones, juvenile hormone and another hormone called ecdysone, or more specifically its metabolite known as 20E. See, ecdysone invokes the molting process, but what that molt does is directed by juvenile hormone. In the presence of juvenile hormone, there's no change in the form of the insect or its structure. A larvae remains a larvae. It might increase in size or instar, but it's still a larvae. However, in the absence of juvenile hormone, ecdysone causes a switching in the gene expression of the insect, changing the form from a larvae to a pupae to an adult. And how that looks specifically in mosquitoes is juvenile hormone affects the metamorphic midgut remodeling and adult cuticle formation. This metamorphic midgut remodeling includes two steps. First, the formation of what will become pupule and adult midguts. These structures of cells in the larvae are different from those in the adult form and must be remodeled. The second step is a programmed death of larval midgut cells. In late instar larvae and fourth instar, larvae exposed to artificially high concentrations of juvenile hormones such as methoprene have their programmed death of the midgut cells slowed or stopped. The larvae are able to pupate, but the surviving pupae have two midgut epithelial layers, a larval midgut epithelial layer and an adult pupae midgut epithelial layer. So what's the challenge? The challenge is the timing of exposure plays a critical role in the success of methoprene. Artificially high levels of the juvenile hormone mimic must be present in the fourth instar level as it begins metamorphosis from a larvae in preparing to become a pupae in order for the effect to take place on the midgut remodeling process and cuticle formation. If the concentration of juvenile hormone is not at the correct level, those processes will continue and emergence of the larvae will happen. Now, let's talk about the formulations and how they help us time the exposure of juvenile hormone. Currently, Target Specialty Products offers the IGR Methoprene nationally in the product line Altosid and is available in liquid, granular, extended residual briquettes. With the liquid formulations of a 5% and 20% solution, the timing of exposure is dependent on us. We must have a good handle on the larval population development and be ready to make the treatment at the correct time. These liquid formulations are great for single brood floodwater species where we get a single cohort of larvae at about the same time. Irrigated pastures and wetlands are a great example of what these floodwater conditions are like. We can time our applications to ensure we don't treat too early, such as first and seconds, and not too late, such as late force or pupae. If a liquid solution isn't right for you, there's Altosid SBG2, a granular product. The SBG stands for single brood granular, and just like the liquid, we must time the application ourselves. For when we can't make a precise time application, we have granular formulations that extend the release of methoprene. These formulations come in a 21, a 28, a 30, and a 35-day extended release. To learn more about these products, check out this video I made to go over how and where to use those types of products. What I can tell you now is that these products allow us to treat several broods of mosquito as they keep the concentration of methoprene artificially high for us. As long as the fourth instar larvae are present during their respective treatment ranges based on which product you use, emergent inhibition happens. Finally, for those situations where you have a continuous introduction of larvae in a small area, such as a stormwater street basin, extended release briquettes are a great way to control mosquitoes for up to 150 days. So there you have it, the IGR Methoprene, what it is, how it works, and where to use it. If you have any questions about Altosid product lines, do not hesitate to reach out to me via phone or email. Next time, we're going to go over the insect growth regulator pyriproxyfen. Until then, thanks, and make it a great day.